Hello, ladies and gentlemen, boys and girls. My name is OctoMan, and today we are taking a look into day and night cycle. The way I would do this. There was a request by Oscar, so I'm gonna try to teach like everything about a day and night circle or cycle, and we're gonna enable and disable lights based on the time we have in our scene. Before we are going to start, I want to once again let you know that there is a free PDF to download for you. Just check down below into the description where I'm gonna teach you 3 strategies to actually finish your game. Also, I want you to take a look into my Udemy courses, which are also down below in the description. Check them out as well, so you get an idea about what type of games I'm going to teach you, and you're gonna be able to enroll over there. So let's take a look into what is a day-night cycle in Unity. So what we're gonna do here is we're gonna make use of our directional light over here and basically just rotate it over the y-axis like this. So we're gonna get like, the sun goes down and stuff like that. And of course, when the light is going in the other direction, it's getting dark. We're gonna see something like on the background, like where the sun is going down and so on and so forth. We're gonna take a look into this over here. So, and depending on auto-generating light and so on and so forth, we may need to deactivate this so it's not like directly rendering and stuff like that, but we don't directly cover this over here. So what we're gonna start is basically with the directional light. So we want to rotate it by whatever the time is we gonna have over here. I used the scene from the last tutorial where we were taking a look into doors and open and close and prefabs and settings and stuff like that. So I'm gonna make use of the same scene. I created some simple street lights over here, nothing fancy overall. We're gonna take a look into them in the second part basically. So first off, I need to create a C# script which is going to take care of the day-night cycle. So I'm gonna name this something like maybe day-night, whatever. And once the compiler is done running, I'm gonna open this in, MonoDevelop, Visual Studio, or whatever. So in this day-night cycle, once again, we're gonna do this based on some simple calculations, or I would do this. So basically, we need to first calculate how many seconds do we have on a day. I'm gonna show you how we do this, and then based on this, we can do like a lifetime cycle, or we can make use of system values based on time, even if that doesn't really make sense, because we wanna have the possibility to speed things up or slow things down based on whatever values we want to implement over here. So what we need is for our actual day-night cycle over there. I'm gonna close my firewall over here as usual. What we need is a connection to our actual light. So I'm gonna put a public, light. So we're gonna have the possibility to drag it in, I guess. So this is basically our sunlight, whatever. And this is what we need to drag it later on into this, like the directional light. We're gonna take this and then rotate it on the y-axis. So we can also, directly on start, reset this light. So basically we only want to make sure that we are starting at 00, like it is like midnight basically. So the sun or the directional light looks down rather straight on the y-axis. So we want to do this in the start method, I believe so. It doesn't need to be public, of course. It's just a void start. A big S at the beginning, open close parentheses. So in start, once again, we can take now the directional light and rotate it downwards. We can catch the current information if we need or want to, but I believe we just go into and set the sunlight, basically the y-axis, to be a new vector. So sunlight dot transform dot, and in this case we want to talk to the rotation over here, like we want to change the Euler angle of that. We can probably, or we probably need to make use of the local rotation, but in this case we're gonna talk to the actual the actual rotation. In this case, we want to create probably a new quaternion, and this quaternion, well, in this case, it needs to be, maybe we transform it to be like a vector, since it is easier to access. Hi, Scale Man! Thanks a lot for tuning in once again. So probably we're gonna make sure that we are using quaternion.euler. So we can basically take Euler, like new vectors or vectors in total, to put in the information. So what we want to do is we want to take the sunlight's rotation x and z and just copy and paste it all over. So basically we're going to take this, since we only want to change the y value on that. So sunlight.transform.rotation.x, but maybe we cannot make use of that because we need to probably put this into a vector. As I said before, we're gonna take a look into this. So the second one is going to be the z value, no, the third one is going to be the z rotation value. And in the center, we're gonna have something like a 0. So the 0, once again, is the y rotation onto that there is 0 part over here. So whenever we go and take now our directional light, and maybe we're gonna put our daylight system onto something like maybe the main camera or anywhere else. Maybe we're gonna make a new object for this, day, night, whatever, and we're gonna drag our script, the day night script, onto this. We're gonna have the possibility to put now our directional light into the slot. When we now press play, we should see that the sun hopefully rotates downwards and it is super dark. Hopefully it is super dark. It doesn't look super dark. And as you can see, it's now at negative 180, which is pretty strange. Let's take a look. What is that value over here? Like a straight going, or kind of straight going upwards, is like a negative 90, it seems. Maybe we need to reset the sun a bit. Once again, there are probably hundreds of possibilities to do that. Let me zero this one completely out. So we start with everything at 0, and now we look upwards, completely upwards, 180 degrees upwards is... okay, so now we're gonna have the 90 degrees or negative 90 degrees on the X rotation over here. As you can see, it's super dark and everywhere. So let's take a look. How do we wanna get this to run? Maybe we're gonna make use of the X rotation. Basically, it doesn't matter. And probably we're gonna have to make use of the local rotation, in this case, not the normal rotation, since the local rotation is, you know, it's different. Now we're gonna have the global rotation. If I show you the local rotation, you can see now we have, like, this is now the x-axis. And if we want to make use of the y-axis, it should be the green one. That doesn't really make sense, I guess. So let me make use of the local x rotation instead of the y rotation over here. So in this case, we can make use of local rotation over here onto the local rotation x. But actually, I'm gonna copy this pretty quick. Copy. Nope, not paste. Copy. Control C. And I'm gonna put this over here into the Z. So local rotation Z. This is going to be like our local rotation Y. And this one here, we're gonna set this one to be negative 90. Let's see if that works. Control Z. Negative 90 is probably not a good one. Maybe we're gonna start not at midnight. Maybe we're gonna start at daylight, so we don't have to implement or increment this part over here, but we need to, in any case, we need to recalculate the rotation of that anyways. So as you can see now at 0, 0 and into this, we're gonna have like a 0, 0 rotation on y and z value, as well as we have the x rotation going to be negative 90 over here. So when we now increase, or if we want to increase time, we will need to, you know, increase this amount here as well. Like we need to rotate the sun by 360 degrees. But as you can see, since we are starting at negative 90, our actual number is going to be here 270. So basically that is not a good one. If we start at 0, 0, as we are at this point, this is kind of like 6 o'clock or something in the morning, I would say. So we're gonna basically go downwards in rotation. And when it is like 12, we're gonna have a negative or a positive 90 degrees rotation over here. Maybe we're gonna have to need, or we're gonna use the Maybe we're gonna use the global rotation. Maybe that makes a bit more sense. Well, I don't think that is going to change anything. Okay, so once again, if we are starting at 0 over here, then we know that it is like 6 o'clock. So I guess we're gonna start at 0, since a complete cycle or day-night cycle can then hit like a 300 or almost 360 degrees. And when we go and rotate further, we're gonna, maybe we need to reset some things here and there, but actually it doesn't matter, I guess. Okay, so once again, we can now put this onto 0, 0, 0 if we like to, or we're gonna be at minus 90. Maybe we're gonna start at 0, so we just remember that it is like 6 o'clock. So how do we know how late it is? Is actually rather simple. We're gonna implement something like a float, which is going to take care of that. Probably we're gonna make this one a public float, so we see what's going on. And this is going to be like our actual time, you know, our daytime. We don't go too much into time and date and stuff like that. We just manipulate the correct things over here and there. So for the calculation, a day has 24 hours, and if we now multiply that by how many minutes we're gonna have per hour, it's times 60. We're gonna know that we have per day 1,440 minutes. If we multiply that once again by 60, because it is like, you know, converted into seconds, we're gonna have a total of 68,400 seconds a day. So when we take this number as our calculation, we know that we need to rotate our daylight by 360 degrees. You guess the idea is like we, you know, say 360 degrees divided by that is going to give us like what 1 second in case of rotation angle needs to be converted to the daylight. And that's what we're going to take care of or make use of. So again, we can also, you know, write this number down, since we know then that this is basically our time whenever we want to or need to reset. So we're going to go back in the next step to 0, for example. So this is going to be our max time, or a day in seconds, something like that, or just seconds. Once again, completely up to you how you want to call this. And it is our number. Did I copy that? No, I didn't. What do you mean by tick system, Scaleman? Maybe I can answer something here and there, if I understand the question, of course. So again, I'm gonna take this calculated number over here. Gonna copy this and try to put this over here. There we go. And this is going to be a float and without the dot in between. Why does this number now doesn't work? 86400. I don't know. Sometimes strange things happen. So once again, just taking care of that, this number is going to be like the day in seconds. Now, what I do is usually all this timing stuff should not happen into the update loop, because it's like keep on busy with that. I would always bring this into a coroutine, since that is easier to tick down and so on and so forth. We can make it as slow as we want, and we can update it like only once a second or something, so we don't do too much over there. Also, we can multiply things and we can increase the step size, but we keep on the seconds tick. So in this case, we're gonna create a new numerator, and this is going to be our whatever, our counter, our timer, our whatever. Doesn't really matter. At least not for me. So our counter just needs to count up by whatever a timer we're gonna put in here. I'm gonna put another stuff here, maybe a public float, another public float, which is going to determine our speed. Usually the speed is set to be 1. That means we're gonna you know, go and multiply that by this daylight number, or by a you know, no time, no delta time, increase that tick, and then update the rotation of the sunlight in case of the Y rotation over here. So, and then we need something else, which is going to be float our current seconds or current time. We need to basically update our current seconds, maybe current seconds. And since we know that we are starting over here, we need to know how much seconds have been passed after 0, after midnight basically, until we hit the 6 o'clock. And we can calculate this rather simple. So basically we're gonna take 360, well no, we just need the time, or the seconds. It's basically, we know this. We know how much hours we have a total, like 24 hours. Let me go up here. So this is our total seconds over there. And if we have just like a 6 o'clock, we can multiply that once again by whatever the amount of minutes we have per here. So we multiply that by 60 and do the same again for the seconds. So we know at 6 o'clock we already have passed or have a current second time of 21,600. So we pass this in here as well. 21,600. Okay, so this is like where our current seconds are going to start. What we now can do is we can take the timer or the counter over here. We of course start the coroutine over here. Start coroutine, open close parentheses, and put in the counter. I'm gonna read your commands, Gaiman. So a system to check the time that RTS games usually have, like when it comes to building, generating resources. No, your English is fine, no worries about it. Well, actually, I have something like that, and basically this is the same thing. Like if a building needs like 20 seconds to build or something, you can basically implement, you know, just a float like this one, and then you tick down by using some kind of a counter like this one. And you need to maybe put it in a queue or something where this is going to, you know, like the first one ticks down, then it builds that, like a queue, like you have 5 things you want to build, they probably have different times. So once again, nothing else than what we're basically gonna create over here by using this counter. Because after a specific amount of time, we can, you know, say, okay, build done, and then we put this outside of the queue. We don't go into queues and end queues and stuff like that right now because it doesn't make any sense for that. But yeah, good idea. Maybe I'm gonna make this one day or the other. So once again, what we need to do is we want to yield return new, wait for seconds, and we want to wait 1 second, 1f. So every time we're going to do a tick, we want to wait before we do any tick. And in this case, we know that we are over here already. So we want to now increase this current seconds time, basically, or this current seconds. Probably it's better to put it into an integer instead of a float, because we only want to, we don't have any, well, yeah, that could be troublesome over here. Float day time. We'll see. We'll see. I'm not quite sure when we need to multiply that. Maybe we have some comma signs, but the rotation only needs comma signs. We're gonna try to work with full numbers here, I guess. So, how do we calculate the angle of the camera like this one? Is rather simple. When it's like we divide the angle. Let me type this out as a command. So what is the angle of the camera, or no, of the light? It's 360 degrees. That's what we're gonna have, like, you know, one cycle. When we now divide this by the amount of seconds we're gonna have per day, like this, I'm gonna copy this, put here. Then we have some number. This is like equal to 1 degree. Whoops. This is equal to 1 degree, basically. So whatever this number is, like we divide this by this, we're gonna have a number which is 1 degree. And this 1 degree, well, it should be, or it's like 1%. Well, basically it's 1%, not 1 degree, it's 1%. So 1% of rotation. So if that is seen like 100%. And when we now multiply that by whatever the current seconds is, maybe in this case this one here, we're gonna get an angle, or a percent or angle. I guess percent. Maybe we need to define or divide that by something else, but we can do a calculation. I guess it's an angle, whatever comes out. So let's do this here pretty quick. So we have 360 degrees to rotate with the daylight. Then we divide this by our maximum over here, so 86,400. And then we're gonna have something like this. So this is, I believe that's an angle. It's not a degree, as you can see, it's the angle. So the angle now needs to be multiplied by the current time. So when we say it's 6 o'clock, we're gonna have, as you can see, a 90 degree over here, like a 90 rotation angle. Then we need to negate this by 90 because we are starting at 0 at this point, I guess. So we say minus 90, and then we should be able to have like our 0 over here is equal to 0. So that is equal to once again, and that is equal to 6 o'clock in the morning. So as you can see, it's like just simple mathematics over here. You know that already from, your mathematics in school and stuff like that. So nothing fancy about this, I guess. So what we now want to do is we want to set the sun rotation based on this calculation to whatever this angle is. If we are going to increase this number, and at a specific point, we might need to reset this. I'm not quite sure if the minus 90 is going to be a troublesome later on. Maybe we're gonna need to recalculate this one a bit different. I don't know. We'll see. So once again, we got this. We now know, okay, we are at 0 degrees basically whenever we do this. So what we now want to do is we want to implement or increment the current seconds over here and pass that in our calculation, and then we set our angle to be whatever the result is. Good. So let's calculate this angle first. So we're gonna create a float. Angle is equal to, basically it's just our x angle, right? So maybe we're gonna name it x angle is equal to, and now we do this 360 divided by our day in second. We can also, type this out. Basically, it doesn't matter. We want to make sure that maybe one of these is a float, so probably I take this one. And we're gonna take our day in seconds. We divide it by that, and we have this 1 degree or 1 angle or whatever. Then we multiply this by our current second over here, and then we're gonna negate it by 90. Let's take 90f just in case, and then we have whatever. So, and that whatever is now stored inside the x angle over here. So we know, okay, this is whatever the time should be. And what we now want to do is we want to increment also every second. We want to increment the actual current second. Or we're going to do this maybe not every once a second. Maybe we're going to put this like into a time.delta time variable. So let's take a look. How can we do this? So we're gonna set current second plus equal our speed times time.delta time. Nope. Time.delta time. And we do this like every once a second, but current second needs to be a float. Okay, that's bad. Maybe we're gonna, oh no, we just typecast this one. Let me keep it as an integer, and let me just typecast this calculation into an integer. I'm not quite sure if that does make sense. Actually it doesn't, so we probably have a problem with that calculation as I expected before. Let's make me maybe we need to round this so we don't have any strange numbers over here. I don't know. So now what we need to do is we just basically take this one over here and copy and bring this over there. So instead of having a 0 over here, we're gonna put our x angle. And so once again, every once a second, we're gonna increase this by our current speed times time.delta time. Then we're gonna have the x angle. We calculate this by, using the 360 degrees rotation, and divide that by our maximum over here. Current second is going to be this, and then we negate it by 90 degrees. So we have the correct rotation angle for 6 o'clock. And if we're gonna now play around, or later on play around with the speed, we should be able to, like once a second, update this one. We can also be a bit smaller with this number, that, like, for example, we're gonna put this not every once a second, maybe 1 point or 0.1 f in this case. So And what we need to do is, since the while loop is, or we are only running this one once and then we would basically leave, we need to have a while loop which is constantly running. So we say something like while true, open close curly brace, and then we're gonna put like everything below inside this while loop. So Control X. And there we go. So this is basically what we need for a coroutine. We just need to make sure that we have a while loop around it. Otherwise, we would just go in, it will leave, and then we are actually no step further. Let's take a look. I'm gonna close my calculator, let the compiler run pretty quick, and let's take a look into if we have any issues, any problems. So as you can see now, my datetime is not used. Probably we're gonna make use of that a bit later on, or just recalculate stuff over here. So my directional light over here, as you can see, it has now a rotation of 0.008. It's increasing constantly, like every or every 10 times a second. So what we can now do is in here we can now increase the speed to be like, let's say 20. What should happening is that this rotation speed on the x-axis is going to increase by far. And if I now say something like 100, it should be even faster. We now need to find a correct way basically to increase the datetime. I try to go into debug mode and see where we are. So as you can see, this is our current second over here, and it's rather slow, I would say. Let's put 1000 into here. So time.delta time is now multiplied by that, and now you can see the sun, or the actual, you know, shadow and stuff like that is going to change over here over time. As you can see, this directional light is constantly rotating. We can see this in the game view, and also you can see the shadows are now going upwards and so on. I don't know what a good multiplier for this is. Maybe we're gonna put a 10,000. So we are having basically a rather quick way to move the actual sun around. And once again, we are updating this like 10 times a second. If you need it a bit further or stuff like that, then you can absolutely do this. You can also go to a local pivot over here, and now you can see it became night. And we're gonna increase that the whole time. And there's one more flaw which might be interesting for us, is once the current time hits the day in seconds time, we want to make sure that we basically you know, bring this one back to 0. And that's what we're gonna do over here. Like whenever we increase it over here, we might want to say something like modulo a day in second. So we keep the actual current speed. Well, hopefully we should be able to keep current speed or current seconds now in modulo of day in seconds. So meaning we're gonna hopefully not overdo it, and we're gonna be, once we hit that number, modulo decreases, or actually sets current seconds back to 0. So I'm gonna play around with these numbers. The 10,000 was quite a good one for a rather quick speed. I'm gonna do something like this. I implement it, save my scene, and let's try again. So as you can see, it's quite fast. So the sun once again now rotates over the local axis of our cam over here, or over our time. Anywhere is the sun. There we go, it's going down. And now in our day cycle, we're gonna check out the current seconds over here, and once they are hitting the 86,400, it should reset itself to be 0. We'll see that in a sec. But it doesn't do it, so we might need to encapsulate this, or we're gonna say something like current seconds modulo equal day in seconds. Maybe that works better over here. And we're gonna get rid of this. Probably I need to just put this into a pair of parentheses. I don't know. I try this out. Maybe that works better. So try again. Don't forget to save. And let's get back into it. And let's see if our current seconds now is going to be equal to, or is going to reset itself when it hits the day in seconds to be 0 once again. Probably I need to convert it into an integer or something. Maybe that is the issue, like between day in seconds and, you know. But we'll see. Should be there in a sec or two. And now you can see it has been resetted and it's now back to 0 and starts all over. So once again, our direction light is going to keep on, you know, bringing the sun up. There we go, there it is. Now it's basically rotating it all over the complete world, all around the world. And so we're gonna have a daylight system. What we can now do is with that, we can also you know, enable lights at a specific time. And we're gonna just need to define what is the time we want to enable these lights and whenever we want to disable these lights. So we can, basically I have these, you know, 3D models over here. We can put some lights under them, like spotlights, so lighting basically down. And at a specific time, we just enable and disable those. We have possibilities, or a lot of possibilities, to find all the spotlights, for example, in the scene, and then we enable and disable them whenever we need to, like disable at this time and enable at this time. Also, we can play around with these numbers later on. Probably we create an extra daylight or, you know, a scene, a class, whatever, which is basically just reading the information from our current time. So if the current time is higher than this, then we activate the light, otherwise we deactivate the light. Something like that, you know, just enable, disable lights. To set things up, I just take one of my street lights over here, and I'm gonna put a light onto this, a spotlight. And currently it's like on the foot on of my lamp. Hi Yanni, thanks a lot for tuning in. I'm gonna do and put it wherever the light should emit from. And I'm gonna get rid of the debug mode because it's easier to see stuff. And now I rotate it by 90 downwards. Well, anyhow, 90 does not work. Let me try again. There we go. So as you can see, this light now creates a light cone on the ground. We can actually put the multiplier up or down to whatever we need. We can also, you know, increase the spread of the light and maybe make it something like that. Up to you. You can, I believe so, also use a cookie. So if you have like a square light as I do, you probably want to create a square light cookie and use that over here as a texture. And you can also define if you want to have like hard shadows, soft shadows, or no shadows at all. So whenever we, for example, would walk into this little light cone, that we are able to see any kind of shadows. As you can see, I have a shadow now under my controller over here. So once again, that is totally up to you if you want to use shadows or not. Of course, shadows are not cool for you know, mobile devices, but in the end, I guess it doesn't matter. So we have once again a spotlight. It's currently set its mode to real time. So basically, when we disable the light, we are actually having an on-off situation over here. Now we just need to steer that complete. Hi Naru, thanks a lot for tuning in. If you can, we need tutorial about dots. What the hell is dots? Please explain that a bit further, if necessary, you know, if possible. So what we need to do is what I want to do is I want to create a prefab, since I am lazy and I don't want to, you know, copy all of that spotlights over here. So basically I just drag it inside my prefabs folder. Is there anything else I need to do? Probably not. So, and I can get rid of the other copies over here and take this now and duplicate this, Control D, and move this to the side. Hold on Control for snap move or something, and find some nice positions. Whoops, what the heck happened here? Those spotlights are strange. As you can see, the outer ones are not going to take or not taken into consideration. Why is that? If you guys know about spotlights and why they are like disabling themselves, then just let me know. Maybe there's something we don't, or I don't have notified or noticed yet. But let's take a look. Well, this one is on. Maybe it cannot render. Maybe it cannot render more than X amount of spotlights, or maybe it has something else to do. I don't know. Yeah, probably it's limited, but I'm not quite sure in which case. So maybe there's an optional way to do this, like having more than X amount of spotlights. But yeah, if you have more questions about them, just feel free to let me know. Anyways, I'm gonna keep on going with that because, well, just to finish things up over here. So we have now these 5 spotlights, and what we want to do is our day-night system should now drive this spotlights over there. So what we can do is with that, I'm gonna close it for a minute. What we now can do is we can create a class which actually has 2 values. The first one, I guess we don't need this one here at the moment. The first one is going to be like a class where the lamp is going to be inside. The second one is going to be at what daytime or day in seconds or current seconds the light should go on or off. So let's pretty quickly do this because I hear some voices behind me. So I'm gonna have to finish this one up quite fast now. So we create a public class, so we can literally put like everything inside a list or something, so it is easier for us to steer that away. We can also just use a single timer for that, or single time, so that could work here as well. Maybe we're gonna do this. We're gonna create pretty quick a float on time, and then we're gonna create another float. Whoops, maybe an on time and an off time. So public float on time, comma, off time. So we can set these times to whatever we want them to be. And what we now want to do is we want to have a list of all the lamps or all the lights we want to enable and disable on these times. So we can probably do something like, or an array. So light array, street lights. And we just put them into this one, public light street lights. And what we can do is we can do a check over there, like if let's say the on time, no, if current time is higher than on time, then we wanna basically loop through all the street lights, and then, you know, make use of them, like enable them. Otherwise we want to disable them. Probably we're going to put this into an extra function, like a bool function, where we're going to do the loop automatically over there. So a bool light sets or setting, and so we basically make a for loop or for each, basically doesn't matter. So for each, tap twice to create this automatically, and we want to have this like in our street lights collection. So street lights collection, for each var give it a name, maybe L for light. And what we now want to do is, maybe it's not a bool, maybe it's just a type void, and we pass in a bool over here, like on or off, bool on. So if on is true, then we're gonna do this. Otherwise, we're gonna, you know, disable them. So we can say something like street lights. Oh no, it's L dot get component. I believe we need to grab the light first. No, we don't. We have it already. So L dot enabled is equal to whatever on is. Yeah, that makes sense. So we pass in on or off, and depending on that, we do enable or disable the light, the actual one over there. And at start, we might want to, depending on the timer, we want to disable or enable them over here. And now we can basically do something like light settings. Where is it? Light setting. And then we can pass in like on, or a true in this case. And if that is not the case, like else, we're gonna disable all the lights. So we say something like light setting, comma, and then we say something like false. And that is a rather simple one. So we're gonna check this like every once or every 10th a second. And now we should be able to do this. So now we just need to define in our day-night cycle over here, we need to define all the lights. We basically just drag them in into this street lights array. So I'm gonna hit the little lock symbol, select all my street lights over here. And probably we can put them into here. Nope, we can't. Okay, now I'm gonna take like all the spotlights. If you want to, you can also check the complete scene for all possible lights. And so you don't need to drag them in as I do over here. Okay, so now we need an on time and an off time. For example, we can say at 8 o'clock we want to make them off, and at 18, like 6 p.m. we're gonna do something like put them off. Okay, so at 8 in the morning we're gonna make them. Yeah, what do we do? Do we make them on or off? Well, depending on the rotation, I believe we need to make them off. So 8 times 60 times 60 is like our off time. So I'm gonna copy this number, 28,000, and put this over here without the dot. And our on time should be like in the evening. So it is, let's see, where's my calculator? It is like at 18 o'clock, or like 18 if you have like, a not an AM PM setting. It's in the evening at 6 in the evening at 18. And we multiply that by 60 and again by 60. So this should be now our on time. Anyhow, the off time did not catch up, so I'm gonna type them in by hand. Is there a... Huh, that's funny. So on time is 64,800. And off time was... When did it happen? I don't know. 6, or no, we wanted to have it 8, so 8 times 60 times 60, 28,800. Okay, hit enter, and I'm gonna save my scene. And now let's try that out. Yeah, thanks a lot, OctoMan. I was a bit... yeah, it wasn't too easy. So let's take a look. When it becomes now evening, it should take the actual light and enable them once it passes the actual time. We'll see. So it should now enable them, as you can see. Boom, all the lights go on because we are now like over this number. There's probably one flaw about it. It's because the 0 number. Okay, so the problem now is we are like over midnight and we reset it to 0. Where is my light? So the light currently has a rotation. Yeah, of kind of, I don't know, what is the rotation of it? It doesn't show me the rotation of the direction of light. So funny. So the problem with that is that at midnight it resets to be a 0. So basically the on time is kind of wrong over here. Since if current seconds is smaller than on time, it disables that, and that is a problem. We need to have like a time span between 1 hour or one time and the other. So if current seconds is higher than on time, and maybe gonna put an end and maybe smaller off time. Does it make sense? I'm not quite sure. And current second smaller is smaller than off time. Does that make sense? I don't know. Let's try. Okay, there was like an instant pop and disabled this already. Maybe I can increase the time a bit so it's a bit faster over here. Where is my speed? Gonna put something like a 20,000 so we can save some time by waiting. So it disables them like instant after start. Now sun goes down. We don't have any enabled lights over here. Now sun goes up again. But lights do not show up. So maybe it needs to be bigger than off time. I don't know. Nope, it disables it quite fast, probably because it was quick 8 from 7 hours, from 6 to 8. So now we are in the evening time. So at 6 it disables or enables them, but at 0 it just resets them. So how do we do this? How do we do this? The complete time I'm gonna need to make some small set over here. So our complete time is this. We're gonna have like an on-off time between this and that. If the current time is, if the current time is like inside the time span, so it needs to be, the current time needs to be maybe smaller than on time but bigger than off time. Or does it need to be vice versa? But vice versa didn't work because of the 0. Maybe we need to do a bit different calculation over here. So we have a total of 86,400. Guys, if you have any ideas, just feel free to help me out, yeah? No worries. So we're gonna have like a current time. We have an on-off time. So what did I set the on-off time again? Gonna make some quick note here. So we have an on time on 46,800. And we have an off time, which is early in the morning. It's 28,800. So whenever it's like lit up enough. So we have the problem that when we are hitting 0, that everything is going to be off. Maybe we're gonna have to calculate them together. So we have a difference. We're gonna take the complete time over here and say, okay, once the current time is like inside this difference. But it doesn't make sense, I guess. So the difference between those two, what is that? Let's see. It's 46,800 minus 28,800. So we have a total sleep time basically, or a total, in this case, the total time of 36,000. So I believe we're gonna have to take this anyhow into consideration. So basically, we need to know that, or we need to say that from this time span until this, so it needs to be, the current time needs to be between these two values, and the current time needs to be between, since we now reset, needs to be between these two values. So if that is the case, we have an on time. So if our current time is higher than that and lower than that and is between, like, is it higher than 0 and smaller than that. If these two and these two match, then we should have like a on time, right? So let me bring this onto the other side. Maybe this doesn't make sense here. So if our current time now, our current seconds, is actually bigger than our on time and basically smaller than our days and second. So I'm gonna put this into parentheses as a big argument basically. So and current seconds is smaller than this. And then we have like our current seconds need to be bigger than 0 and current seconds needs to be smaller. Maybe we don't even need the parentheses over here. And smaller than 28,000, actually our off time. Then we should be able to put this, and since these are all on or our AND operators, we should be able to have light on between those. Let's see. Gonna press play here. Once again, I'm not quite sure if that works or if I have any mistake I've done over here. So lights are off, that's good, at least for this time being. But now we don't have anything, so everything is off. But I want to see if we have like a rising. Nope. Okay, so maybe we're not gonna have to put an OR operator and put these like in between. So if that is the case or that is the case, we want to have like light settings on. Maybe the second argument, like maybe we need to be more precise over here. So else if our current second, maybe we're gonna do it vice versa. Else if our current second is actually smaller than our on time and current second is bigger than our current second bigger than our off time. Does that make sense? Maybe not. Let's try it out first with the OR operator. So if we are between on time and the maximum possibility, like between this and that, yeah, maybe you're right. But the values are, we know the values. We know the values. Because that is our current time, is our actual value. But probably you're right to get the measurements if they are right. Okay, so that looks promising. So let's see if we are now able to get light on. Now we need to hit the 0 mark. And we did hit the 0 mark. And once the light is up far enough, then we should go off. There we go. Pretty good. So now everything works. So the OR operator was doing the trick over here because we have like two different time spans or spans between these, because we have the reset to 0, like we cap it over here. We're gonna need to make sure that we have a time zone between 0 and whatever the off time is. In this case was 8 o'clock, as well as we have another time span between the the evening time and the maximum possible the maximum possible time. So we needed to put an OR operator. So one of these need to be true, like this complete set needs to be true, or this needs to be completely true. If both of that or one of these is not matching, or actually both of these are not matching, then we're gonna disable the light, like here. Good, so if that is the case or that is the case, then the lights go on, otherwise the lights go off. I'm gonna save my script once again, just in case. We don't need to have this over here because it doesn't work or doesn't actually make sense to put it in there. And there we go. So now we have a fully running daylight system over here. We can increase or decrease the speed of that. If we keep this number onto 1, then it is like a real time or kind of a real time value over here, but we can multiply this by 20,000 or whatever the value is. And now at volumetric light, yeah, of course, Mr. Evil Jenny, I will not. So we gonna, you can, I believe there is some effect or post effect, something which can give you the volumetric lights over there. So just check out the assets. So I believe there is some post process or something like that. Probably post processing stack is going to help you out with that as well. Oh, and by the way, if you want to play around with materials, like for example, giving here these lamps kind of emission, you can do this as well. You just swap materials. You know, so for example, you're gonna take this white material here and give it some emissive shine and something like that. Gonna put a post processor on that, and then you have like a shine over here for this also. Okay, so that's everything for the stream I wanted to show over here, and today we have a full cycle. We have did some strange calculations over there, but everything is running now in a coroutine. We don't go into an update loop, and everything is fine. If you have any question, now's the chance. Otherwise, feel free to comment below when you have any questions later on, which are not inside the stream, as well as check out my free PDF, 3 strategies to finish your game, into the description below as well, and also check out my Udemy courses. So I'm gonna give you 1 minute to probably ask another extra question over here. Gonna do some cleanup meanwhile and let you type if you have any questions. Feel free to do so right now. No questions, guys. I'm glad I hope I served you well. So I hope you're gonna have a good day and enjoy your weekend, and yeah, create some awesome games, of course, in the future. So thanks a lot for tuning in. I hope you enjoyed this one, and see you in one of my next tutorials or live streams. Have a good one, enjoy your weekend, and bye bye.